Some things you remember, previous class we studied about magnetic force given by Q into V cross B, right? So it's like QVB sine theta, and Lorentz force is the sum of the electric force plus magnetic force, that is QE plus QVB sine theta, right? So let's take one problem, which is, it says a straight wire of mass 200 gram. So the mass that is given to us is 200 grams, and it's a straight wire. It's a straight wire whose mass is 200 grams and has a length of 1.5 meters. So the length is equal to 1.5 meters. Okay. Carries a current of 2 amperes. So it carries a current of 2 amperes. And further it says it is suspended in midair. So it is suspended. This particular wire is suspended in midair. That means, let's say this is a wire. The wire is actually suspended. It is ladak raha hai wo. So this is suspended midair, straight wire. And further we say suspended midair. Suspended midair by a uniform horizontal magnetic field. So there is a magnetic field also, a magnetic field, and that magnetic field is something B. B is the uniform magnetic field. B vector is B. Have you understood the problem? They are asking now, what is the magnitude? You need to find out what is the magnitude of this B. So let's first understand this problem. There is a wire, and the wire is like a magic. It is suspended. The wire is suspended midair. Condition is that the wire is carrying some current in it, and it has got a particular length, and it is suspended midair. Suspended midair means if you actually try to draw some sort of force diagram, then what is it? Whatever it is, don't you think the wire should have a weight? Yes. And for that, it should come and fall down on the ground. W is equal to mg, and it should fall down, but it's not falling down. It is suspended due to a magnetic field. So which side the magnetic field must be working? Right opposite. Agreed. So there should be, and due to that magnetic field, there should be a magnetic force. So that magnetic force must be working right opposite. So the magnetic force must be working on this side. And so this is, say, F magnetic, right? And under equilibrium condition, when it is actually floating, this force must be balancing the weight. Otherwise, it can't float. As simple as that. Agreed. We need to find out what is the value of this force, and then we need to equate it with mg, and we should be able to find out, right? So if we see Rm, m is given here. This is the value of m, which is equal to 0.2 kg. Okay, and g we will take as 10 meters per second square, straight wire length. Now the problem that you will face in this question is, you know that F is equal to Q V cross B, V cross B, and that is what this is the formula. But there is no mention of any sort of Q out here. There is no mention of V out here, but there is the mention of charge out here. So we'll see that formula later, but a new formula we will be seeing over here. Now let's see. What is velocity? Velocity is some distance traveled over time. Do you agree? Velocity is, and we are talking magnitude. So all this, so velocity can be written as distance. So there is some distance over time, and you have got a Q out here, and you have got a B out here. Q over time is what, beta? Current. Is current mentioned here? Yes. And distance, the length of the wire. See, this is the formula for force experience. Another way to appreciate this is the formula for force experienced by a single charge. Single charge. But here we are having how many charges? Millions of charges. So if you are seeing the force experience, so if you see the force experienced by this conductor is the force experienced by all the charges, you should add all the charges, and it is actually over the length of the conductor. So the other formula that we have here is that force is also given as I into L cross B, we say. Acha, here L is actually a length vector. Like you studied area vector in Gauss theorem, L is a length vector. How should you take the L vector? In the direction of the current. So they said that there is a current which is flowing out here. Okay, so let me just draw the current. The current is, say, flowing out here, and this current is how much? 2 amperes. Got it? So this formula we will be seeing in motors and all. When we do electromagnetic induction, we will be continuously using it. ILB sin theta. L is the length. Yeah, in grade 10, did you not study about force experienced by a current carrying conductor? A conductor which carries a current, and you place it in an external magnetic field. So current is there, length of the conductor, and this is the external magnetic field. Now this magnetic field is created by the conductor itself. Now one question. This is magnetic field. You are saying that the force is acting in this direction. This is force, that is field. By the diagram or the question given, the force has to be upwards. Otherwise, how will this wire suspend in midair? It can't suspend. But when we are actually trying to solve, whether you solve it with this, you can't solve with this, you have to solve with this. So the magnitude of the force will be given as what, beta? The magnitude will be ILB sin theta, where theta is the angle between the length vector and the B vector. So question arises, length vector is on which side? This side. Which side is the B vector? Which side is the B vector? So to find out the B vector, one of the easy way is use right hand thumb rule. So the B vector will be actually, you see the B vector is actually coming out this side tangentially. Or else you tell me, what is F? F is a cross product of these two. And F should be perpendicular to both V and B. F should be perpendicular to both V and B. That means L and B, F has to be perpendicular. F is perpendicular to B. F must be perpendicular to, that means V also, or in your case L also. That means L and B should be perpendicular to each other. So what is the value of theta? 90 degree. Did you understand the logic or not? F kaisa hai beta? The F is a outcome of a cross product. A cross product is a vector which is perpendicular to both the vectors. So the cross product is perpendicular to V. In this case to L. So therefore it must be perpendicular, L must be perpendicular to V. Got it? So we say that if you equating the forces, so just equate the forces, W should be equal to the magnetic force. Right? W is what? Or let's say the magnetic force. The magnetic force is I into L into B sine 90 should be equal to mg. I think now you should be able to find out the value of B. B is equal to M. M is how much? 0.2 multiplied by 10 divided by length. How much is the length? 1.5. And how much is the current? The current is 2. And sine 90, sine 0, sine 90 is 1. That means it becomes 2 into 10 divided by 15 into 2. So 2 5s are 10, 5 3s are 15, and 3 20. So this will be 6 are 18, 6.67 Tesla. Let's check. 6.65. So they have taken 9.8, we have taken 10. So our answer is 6.67. Did you understand how this is done? These type of problems are very, very common problems and very much expected. ऐसे problems खूब आ जाते हैं. Easy है, बस दिमाग लगाना है. So put that formula also F is equal to QVB, F is also equal to ILB. Fine. The next question is easy. You can give it a try on your own also. So let's move to the next topic, which is motion in a magnetic field. Motion in a magnetic field. Okay, so I have to use my phone. I don't know, I left my notes today. Motion in a magnetic field. All you're going to study out here is that what happens to the, if a charge is there in a magnetic field, if a charge is in a magnetic field, how is its motion and how does the motion get affected? Okay. So by now we know one thing, that if you have a magnetic field can never change the speed, it can always change the direction. ठीक है ना? तो ये कुछ notes आप लिखिए. We write the key idea. The key idea. Because from here you might get reasoning based questions. Key idea: a magnetic field cannot change the speed of a charged particle. This is what we studied in last class also. Electric fields can actually accelerate. Magnetic fields can always change direction. So you write, magnetic field cannot change the speed of a charged particle. Magnetic field, and if you read these notes, these are sufficient. So B cannot change speed of a charged particle. So what can it do? It can only change the direction of motion. B can only change direction of motion. This we wrote as statements. Now we need to understand that why does this happen? Why? Okay. So if you see the magnetic force F is given by Q into V cross B. V cross B. F is given by. So what is F? F is perpendicular to V. F is perpendicular to B also. Now observe for this one and this one. Can I not write that F is perpendicular to the velocity vector? And F is perpendicular to the velocity vector means F is also perpendicular to the displacement vector. Displacement happens in the direction. Now you have a displacement. You're going this side. You're going this side, and I'm pulling you with a force on this side. Your motion's direction only will change, right? That is the reason why the direction. So you can write a note. F is perpendicular to V, which concludes that F can only change the direction of motion. And force is always perpendicular to velocity. Force is always perpendicular to velocity. Our next question is why F cannot change speed. Why F cannot change speed? This is our next question. Why F cannot change speed? F being perpendicular, due to this reason, it can only change the direction of motion. Write the next question. Why F cannot change the direction of speed? Okay. Now, can I write that F being perpendicular to V, I can also write that F is also perpendicular to the displacement vector. Clear? Easy, simple languages we will go. So let's see what is the work done in this process. Work done is given by F dot displacement, right? Now this is what? This is F S cos theta, which will be cos 90, and cos 90 is 0. Work done is 0. If work done is 0, then change in kinetic energy is also equal to 0. Whenever work is done, if you do work, if I do work upon you, then your kinetic energy will increase. If you do work, your kinetic energy should decrease. Now, since there is no work done, the change in kinetic energy is 0. Is this logic understood? So, if the change in kinetic energy is 0, what is kinetic energy? That means you can also write that half mv square is equal to 0. M never changes. That means V, half mv square means delta, change in kinetic energy. Need not write this part. Change in kinetic energy 0 means velocity, or I'll write change in speed is equal to 0. If kinetic energy does not change, speed also cannot change, because kinetic energy is half mv square. M does not change, m is always constant. So if kinetic energy is not changing, this means speed is also not changing. Is that fine? Clear? So let's see now to understand. So when a charged particle is moving in a magnetic field, what is the understanding we have? That when a charged particle moves in magnetic field, there is a magnetic force. The magnetic force is only going to change the direction of the motion, but it cannot create any sort of acceleration. That means it will not be creating any sort of, not acceleration, I should say, it will not create any change in speed. And this is because the magnetic force is perpendicular to velocity. That means the magnetic force is perpendicular to the displacement. So it does not, it only thing that it can do is it can only change the direction of motion, and it does not change the speed because the work done is 0, Fs cos 90. And if the work done is 0, then what is 0? The change in kinetic energy is 0, which means the velocity remains constant. Now some criteria that we will see. The first criteria is case 1. Velocity is perpendicular to magnetic field. Magnetic field. So you have a magnetic field, and in that magnetic field there is a charge which is moving, and the charge is moving in such a manner that the velocity vector is perpendicular to B. You will ask, sir, why did you take this special case? No, we will take another case also where it is moving at an angle. So in this case, what is the magnetic force? As you learned, is given by QVB. Agreed? QVB. Now this magnetic force will always act towards the center of the path. I'll explain that, what it means. And towards the center of the path means it will be acting like a centripetal force. Okay, centripetal force. Imagine, children, imagine that you have tied a string to a stone. A very common example, grade 11 type of, okay. You have tied a string to a stone. And you are whirling the stone all across, okay. Tied a stone here. And this is the center. And then you are moving it. Then what happens? Why is it moving in a circular path? There will always be a inward pull. The inward force is always known as the centripetal force. This is centripetal force. Centripetal force is taken up by different type of forces takes its role. Sometimes the tension in the string will take up the centripetal force. Sometimes when you are taking a big turn very speedily with your car, friction is actually making the work of centripetal force. So different forces take. And centripetal force, when you see from what is the force that is actually centripetal force that is acting on this vehicle, this will be on this body, will be given by mv square by r, where v is its velocity and r is known as the radius. Okay. So the magnetic force is also acting. Now your magnetic force is actually, the magnetic force is acting. If you see your charged particle wants to move in this direction with a velocity v, and the magnetic force is actually pulling it perpendicular to the charged particle. So it will be actually working in such a way that it will try to now move it in a circle. Every time there is an inward force. Why does an electron spin in an orbit? Because the electron has the electrostatic force of attraction which is pulling it towards the nucleus. Every time you pull, everywhere you pull, you will be actually making a circular motion, right? So here we will say, I mean, swinging stone, that you have understood, right? So put a line. Magnetic force continuously pulls the charged particle towards the center. This magnetic force continuously pulls the charged particle towards center. And that means the magnetic force is actually behaving like a centripetal force, and your big thing is particle moves in a circle. Now please remember, you are seeing a very special case where the velocity is perpendicular to the magnetic field. If the velocity is perpendicular, the velocity need not be always perpendicular to the magnetic field. So please understand that in normal cases what it will be, velocity will be always at an angle to the magnetic field. But if it is perpendicular, try to observe the thing. If the velocity is perpendicular, then this object will be always moving in a circle. Have you understood? However, velocity will not be always perpendicular. You've taken a very special case. Velocity will be at some angle. We will see that. But if it is perpendicular, then it will be moving in a circle. And then if it moves in a circle, we should be able to find out what is the radius of that circle and all. So let's do some derivations for that. So our derivation is the magnetic force will be now behaving as the centripetal force. The magnetic force will be the centripetal force. So QVB becomes equals to mv square by r. V takes away v square. And this gives you the definition of R. So R is equal to mv divided by QB. Keep this relation, you will need this. This is R. R is, what is R? R is the radius of the circle or the circular path that charged particle will be traversing when the magnetic field is actually, sorry, the magnetic force, when the velocity is perpendicular to the magnetic field. When the velocity is perpendicular to the magnetic field. Okay. A couple of things out here. Larger mass. If the mass is large, suppose you have a charged particle which is very heavy, then what happens to the radius? The radius will be greater. Then higher speed. These only will come as 1 mark, 2 mark question. You will have the radius will be greater. Imagine if you are taking a, if you take a turn and you are cycling at a higher speed, won't you take a longer radius? You can't take a sharp turn. Larger mass, so automatically the larger mass will sweep a greater radius. Now the next thing we see is, what about greater B? If the magnetic field is more, obviously you're being attracted more, so the radius will be smaller. Radius will be smaller. And if the charge is larger, then obviously the radius will also be smaller. Acha, in grade 11, you remember angular velocity. V is equal to omega r. Omega is angular velocity. Angular velocity. V is the linear velocity and r is the radius at which you are rotating. Okay? Now we will see an expression for angular velocity, also known as cyclotron frequency. Angular velocity. Angular velocity is also known as cyclotron. Why is it a cyclotron? Because if you have a charged particle, then it moves in a circle. How does it move in a circle? Make the velocity perpendicular to the magnetic field. So if you see your microwave ovens, the heart of a microwave oven is a device called magnetron. And they'll always say the magnetron has gone bad. If that is what is actually going to make the charge move. And the charge will be made to move in a movement, it will make it move and accelerate. If it accelerates, then electromagnetic waves are created. Microwave is created with which you are actually cooking food. So when you start the microwave oven, there's a sound. The magnetron has got activated. Therefore, you cannot put any metallic object inside a microwave oven. I hope you know that. Darato, khatas, it will just take it away. So angular velocity, let's come. So V is equal to omega r. So we are supposed to find omega. Omega is equal to V upon r. Children, remember one thing. Angular velocity, this is just for your knowledge. Angular velocity is a vector quantity. Angular velocity is a vector quantity. Velocity, na? And its unit should be what? Its units will be radians per second, rad per second. Angular frequency also has the same unit of rad per second. They're exactly not the same. This is number of cycles per unit time. But sometimes angular velocity is also called like angular frequency. Not exactly same. Unit wise they are same. Angular frequency is a scalar quantity. Angular velocity is a vector quantity. Both share the same unit of rads per second, radians per second. So whatever is the angular velocity, what we will calculate now is the cyclotron's frequency. Okay? So let's do. V you know is V. What is the value of R that you found out just now? MV by QB. Yes or no? So let's arrange this. V divided by MV. So this is into QB by MV. V and V cancels. Okay, V and V cancels. And then you get the value of cyclotron frequency, which is QB over M, or the angular velocity. Another important formula and some stylish observations you can write down here. I want you to write down. Angular velocity is independent of speed. Just look at, do you see a V quantity out here? There is no V quantity. Angular velocity is independent of speed. So write an explanation on which sometimes they may question you. So you write the explanation. That is why particles with different speed, your speed and my speed may be different. Please understand. But if our ratio of QB over M is same, we will both have the same angular velocity or angular frequency. That's why particles with different speed but the same Q by M. Now see, listen, children, there is a magnetic field which is B. There is a magnetic field. First understand, there is a magnetic field which is B, right? Here there is one particle called P1 and there is another particle called P2. P1 is moving with the speed V1, P2 is moving with the speed V2. Understood? However, if I look at the ratio of P1 must be a charged particle. If I look at the ratio of, say, its charge is Q1 and its mass is M1 and its charge is Q2 and its mass is M2, and so by some hook or crook method you made these two equal. Q1 by M1 is equal to Q2 by M2. That means both the particles will have the same angular velocity, though their velocities are different. Very interesting observation. This is how actually a cyclotron works. A cyclotron can make two particles move with the same angular speed, angular velocity, not angular speed, angular velocity, though their linear velocities are different. Because if you can somehow make their q by m charge same and then introduce them into the same B, then they will have the same angular frequency. So that's what you are writing. So write that explanation. That is the reason particles with different speed but the same q by m rotate with the same angular frequency in a given magnetic field. Have you understood? That's you found out. That is the interesting thing. Angular velocity, that is what is happening when you are in a magnetic field. Your question is very correct because you are seeing it from grade 11 syllabus. In those syllabuses, there was no magnetic field. But when you have a magnetic field, you have a magnetic force. The magnetic force is QVB. And the magnetic force wants you to keep you in a circular trend. We are having a very typical case where V is perpendicular to B. So the magnetic force wants to keep you in a circular line. So the magnetic force is behaving as a centripetal force, which is trying to pull the object towards the center of rotation. Now I equate these two. I get a value for R. Agreed? And that value of R I am putting in V is equal to omega R. And then my omega is void of V. Your observation is very correct, but that is correct in generic world where there is no magnetic field. But if you have a magnetic field and the velocity is perpendicular to the magnetic field, then the angular, we are not saying that this is angular velocity of any object. This is angular velocity of a charged particle moving in a magnetic field where the velocity is perpendicular to the magnetic field. And such a device which works on this principle is called a cyclotron. The course is reduced. They have just kept this portion. And a cyclotron's angular velocity is this. It does not carry the V component, which is your advantage, that you can have two different particles with two different velocities, but you can make the angular velocity same. Clear? Okay. So we have got now, this is also known as the cyclotron frequency. This is known as the cyclotron's frequency. Okay? So let's quickly write what all we have found so far. Force is given by QVB. In some cases, it is also I into L into B. I, L, B. We have found this one. Then what did we find? We found the radius. The radius is equal to mv by qb. Then we found out the angular. Here we found out that the q by m ratio should be n to b. qb by m. Clear? So this was our angular velocity. Alright? Now since you have got angular velocity, that is omega, or the angular frequency, qb by m, right? Fine. Time for us now to calculate the time period. Time period. Again, all grade 11. T is equal to 2 pi by omega. 2 pi by omega. So let's calculate. T is equal to 2 pi by omega divided by omega. So into m by qb. This is the definition for time period. So you can again write time period is also independent of V. There is no V. Once you know time period, now you are trying to see the frequency. cyclotron's frequency. That was angular velocity. Now you are trying to see frequency. Remember one thing, angular velocity and frequency are not same thing. They just share the same units. So frequency is always equal to F, which is given by 1 upon T. So it becomes QB by 2 pi M. Did I write that as cyclotron frequency? The previous one, you mentioned this as QB by VV. Okay. Omega. Yeah. So this one you can write it as, this is the cyclotron frequency. That is angular velocity. Angular velocity and frequency will, angular velocity and angular frequency share the same unit, rad per second. Angular velocity is a vector item, angular frequency is a scalar item. This is the cyclotron's frequency. So let's add up. Time period is 2 pi by omega, so it becomes 2 pi m by qb, and frequency is equal to 1 upon time period, so it becomes qb by 2 pi m. This is the frequency. After this we will have the normal Biot-Savart laws and all, where your ILB question will come. Now our next part is, now, so we can think it like this. See, let's say there are 3 axes, right? Just for your understanding purpose. So till now you studied what? If the velocity is perpendicular to the magnetic field. Okay, if the velocity is perpendicular to the magnetic field, then the type of motion that you will have is a circular motion. So your motion would be circular motion. The motion will be like this. Are you understanding? Suppose the velocity is in this direction, the magnetic field is in this direction, particle will be in a circular motion. Now our case 2. Case 2 is when velocity is at any angle with the magnetic field. All right. So let's create one velocity vector. Say the particle is here and velocity is at any angle with the magnetic field. So let's say, let me say that this is the magnetic field and this is the velocity vector. Now, as per our vector resolution, what we can do, we can resolve this velocity vector. We can resolve this in such a manner that there will be a horizontal component which will be along the magnetic field. Okay? And there will be a vertical component which will be perpendicular to the magnetic field. Right? You can write this. You can write this as, this is the more generic one. So I can write this as V parallel, means V horizontal, and this is V perpendicular. See the stylish thing now. V perpendicular with the magnetic field you have already studied. What does it do? It makes the vehicle, it makes the body move in circle. It makes the body move in circle. Now we are going to see what happens, the impact of V, if the V is parallel with this particular B. V is parallel with this V. Okay? Aye. So let's see effect of each component. Effect of each component of V. So number one we are seeing is parallel component. So did you understand what we did? We took the velocity at any angle with B. So we are seeing the parallel component. So if you have a parallel component, the parallel component is V parallel. In this case, theta is equal to 0 degree. What is theta? Theta is angle between V parallel and B. Theta is always the angle between this. And let's see what is the force. The force is equal to QVB sine theta or sine 0. Sine 0 is 0, so this is 0. No magnetic force acts, so V parallel remains constant. Is this logic understood? If you consider only this fellow, then the horizontal component of the speed remains constant. There is no force along the horizontal component. So if there is no force, there won't be any sort of what you call acceleration or any other thing. Let's see what is happening with the perpendicular component. This is only a unique topic in this chapter. Perpendicular component. The formulas that you are finding here are only generic to this cyclotron topic, but otherwise other formulas are for the chapter, like QVB you can use, ILB you can use, but this particular topics like the radius is equal to MV by QB and what is the frequency, that are very particular to this, okay? And this is V perpendicular. In this case, theta becomes 90 degree and the force is given by QV B sine 90, which is equal to QVB, right? And that's what we studied, that V perpendicular produces circular motion. Circular motion. Okay. Now, this is we'll see these two. You have a velocity component. This component is going to create circular motion. This component remains unchanged. Now, if I combine both motions, combining both motions, just try and think in your mind. Something is moving in circle and yet you are pulling it. What will be the shape of the motion? Spiral or helical. This velocity moves constant. One component of the velocity is moving constant. So there's a horizontal displacement and there is a vertical one which is at 90 degrees. So perpendicular displacement and a horizontal displacement, and you are rotating. In that case, you will make a have you seen soft cone in Magnetism? And you do what? Pull it down. So what is the shape you're getting? The Magnetism dispenser is never giving a helical shape. How does the shape come out in your cone? Like this. It is the Magnetism dispenser is only going to dispense in circular manner. You are creating a horizontal pull down. So what is the shape you are getting? Helix. So we say that combining both motion, this is what is interesting. We can say that if you combine both the motions, then the motion is spiral or is a helix. Helix. So this one will give you circular motion. This one will give us circular motion. This one will give us horizontal motion. Any doubt? Tell me, don't worry. Spiral means it will move and take spiral binding. Radius is not going to reduce. You will be moving. because you have a linear movement also. Spiral does not mean that it will be ending. See, in McDonald's, because no, in McDonald's, he's reducing the flow. If he doesn't reduce the flow, then how is your cone coming out? Like Murukku, that Telugu snacks जो होता है ना, Murukku से वैसे आएगा, जलेबी जैसा गोल 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 आएगा. Because he can't give you so much of ice cream, so he's going to reduce the flow. So you just imagine how the cone is being filled. Suddenly pull it, and by that time it's doing, and he pulls it down and takes it up. But here that's not there. So you have a circular motion which is created by V perpendicular. You have a horizontal motion which is given by V parallel. So as a result, what will be our shape? Our shape will be that of a helix now. Helix means a spiral. It does not mean that your radius is getting reduced. Your radius, spiral binding. It will go ऐसे घूम के जाएगा. अभी समझ में आया आपको? Good. Have you done screw gauge experiment in grade 11? Have you heard about something called pitch? Pitch. You remember what is pitch? Pitch of the helix. Forgot. Pitch of the helix. Hey. Pitch is very important in swing also. In one rotation, pitch is seen for a screw. See, it's like this. In one rotation, what is the linear feed obtained by the screw? A screw goes in and comes out, right? If you rotate once, what is pitch? Pitch is a linear movement. In one rotation, how much movement did you do? Yeah, you can write down. So we are doing pitch of the helix. So write down, pitch is the distance traveled along the magnetic field. Pitch is distance traveled along magnetic field in one complete revolution. In one complete revolution. So how much distance did you travel? Distance is always given by speed multiplied by time. So your speed. Now which speed will you take? Pitch. Pitch mein the parallel one. Very good. We will take the parallel one. And we will multiply it with what? We will multiply it with the one turn means time period. Okay? So pitch is given by V parallel multiplied by T. But what is the value of T that you had got? 2 pi m by QB. Okay? So your pitch is given by V parallel 2 pi m divided by QB. These are all cyclotron specific only. Huh? So let's make one summary. Most 1 mark questions expected. If V is equal to 0, then what happens? Particle is at rest. Particle is at rest. If your V is parallel to B, then particle moves in straight line. ठीक है ना? If V is perpendicular to B, particle moves in a circle, and V at any angle with B. यही आपके टेक्स्ट बुक में ना क्लियरली नहीं लिखता है. अब ये हो गया ना, now your notes becomes very easy. Tell me what will happen here. Particle moves in a helix. Helix is a spring. So keep your formula sheets ready. You will need them Magnetic force is always perpendicular to velocity, so it does not do any work. That's our summary. Speed remains constant, only direction changes, and radius depends only on the perpendicular component. Radius has to do nothing with your sorry, not radius. Angular velocity has nothing to do with the velocity of the component. It's devoid. I think there was one problem on this. Actually, the next ones become more easy, interesting, like Biot-Savart law, which we will do in next class. ये problem कर लेते हैं, आइए. And you only will tell me the formulas, huh? If you know formulas, you can solve it. What is the radius of the path of an electron? So we have to find out the radius. Radius unknown. Acha, is an electron a charged particle? Yes, it's a charged particle. That means, and they're saying it's an electron. So if it is an electron, straight away you need the mass of the electron. The mass of the electron is 9 into 10 to the power minus 31 kg. And if you look at the charge of the electron, that is equal to 1.6 into 10 to the power minus 19 coulomb. Okay. And you don't write negative and all these things. It is this electron is moving with a velocity v, which is given by 3 into 10 to the power 7 meters per second, almost at the speed of light. Okay. In a magnetic field B, which is given by 6 into 10 to the power minus 4 Tesla and perpendicular to it. So perpendicular. So what sort of motion you expect now? Circular. That's why you are asked to find the radius. It's okay, it's circular to it. What is its frequency? You have to find out the frequency. Children, to find out the frequency, all you need is, if I go like this, omega, okay, is time period is equal to 2 pi by omega. Whatever it is, frequency is 1 upon time period. So we will need this relation. And finally, you have to calculate the energy in keV. Calculate the energy. So first find out the frequency, and then we have to calculate the energy in kilo electron volt. Don't worry about that. Let's find out the what do you call frequency. Frequency and also the radius. Number 1, number 2, number 3. So radius निकालते हैं. चलो, radius का फॉर्मूला क्या था? mv by mv divided by q into b. Very easy. What is the value of m? 9 into 10 to the power minus 31. Velocity is 3 into 10 to the power 7. And q is 1.6 into 10 to the power minus 19. And b is 6 into 10 to the power minus 4. सबसे पहले 10 to the powers को सुलटाओ. So it is 10 to the power minus 31 plus 7 plus 19 plus 4. Right? And 3 will take it up as 3 2s are 6. So it becomes 9 divided by 3.2. 9 divided by 3.2, which is almost equal to 3, approximately 3. 3 3s are 9. 3 into 10 to the power, how much is the speed? Minus 31. 17 and 20 gives me 27. So this is 26. 26 plus 4 is 30. 30 and 3 into 10 to the power minus 1 meters. So it's a 0.3 meter, roughly. Yeah, they have found it as 28 centimeter. I have approximated. Where did I approximate? I approximated here, see. So they have 28.6 centimeters. Okay, can we find out V is equal to omega R, right? Then omega T is equal to omega by 2 pi. So from here itself we can find out. So V is equal to omega R. So T becomes equals to what? T becomes equals to 2 pi by omega, that is V by R, right? So T is equal to 2 pi R by V. So F is equal to V by 2 pi R. Check whether we know all the datas. We do know all the datas. So you'll be able to solve. ये समझ में आया तो? Which one? This one? So what is the formula you have? QB by, what is the value of B? B is given in Tesla. Yeah, you can solve it. You can do it. I'm saying if you forget, you can use this also. So frequency is not an issue. Frequency nikal gaya. And then you have to find the energy. Energy is what? Energy is kinetic energy, which is equal to half mv square. Now this will come in joules. Joules. 1 electron volt is 1.6 into 10 to the power minus 19. So you have to use that. Half mv square. And then you have to convert it into kilo electron volt. First convert it into electron volt and then divide it by 1000. That will give you kilo electron volt. Check your data, and if you want some calculation, tell me. I have a calculator, can help you also. First find out frequency. Let's match frequencies data. How much is frequency? V is how much? 3 into 10 to the power 7 divided by 2 into, how is the value of R we got? Book got it as 0.28. So I'm taking as 0.28 itself. 1.70 or 1.71 into 10 to the power 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. What's the frequency? Frequency. Yeah, 17 megahertz. Correct. So the frequency is coming 17052315.33. This is the frequency's value. So many hertz. Now just put here 1, 2, 3, 4, 5, 6. So it becomes 17 megahertz. Correct. Our value is correct. And then energy. Velocity is how much? 3 exponent 7 and square it up, right? And you multiply it with mass 9 exponent negative 31 and then divide it by 2. Yeah, so we are getting our energy is 4.05 into 10 to the power minus 16 joules. Just check, is this the energy with your book?
Yes.
Okay. Now you have to convert this into kilo electron volt. First convert into electron volt. Electron volt means energy gained by an electron when the potential difference is 1 volt. How much energy does it gain? 1.6 into 10 to the power minus 19 joules. So 1.6 into 10 to the power minus 19 is equal to 1 electron volt. So 1 joule is equal to that by this. So this many is this divided by 1.6 exponent minus 19. So our value is some 2531, but it is kilo. So multiply by, divide by 1000. 2.5 is the answer. Yeah. So the energy is now equal to 4.05 into 10 to the power minus 16 divided by 1.6 into 10 to the power minus 19, which is giving you how much? 2531.25 electron volt. Now if you then 2531.25, if you divide by 1000, then your answer will be coming in keV, which is 2.53 keV. Just a calculation problem. They should introduce calculator, then only people will find interest in doing problems. बिना calculator का तो बेकार है. ठीक है? Next chapter, next class onwards, real things that Biot-Savart law will come, Ampere's circuital law, all very easy. But those will be used in electromagnetic induction. The chapter after this is the theory chapter, diamagnetic, paramagnetic. So that I think I'll give you just notes. आप पढ़ने से काफी है, उसमें कुछ समझाने का कुछ है नहीं.